Hi, everyone. For those of you that don't know me, I'm Tricia Rodriguez, and joining me for our demo this morning is Maris Ensing. So let's get started. Today, we're going to talk about what we at MAD Systems have done to prepare our building to create a safer environment for our team. Maris will walk you through the space to have a look at the changes and explain what we used and the additional things that you'll need to consider when using these applications. Then I'll meet up with you again with Maris to answer any questions you may have. So before we get started, just a few things we need to cover for housekeeping. We welcome your questions, so please feel free to use the Q&A panel for your questions. We'll take the last part of the session to address them. Jessica, I think you need to mute. For those of you unfamiliar with MAD Systems, we're an award-winning technology company specializing in an audio-visual systems integration and interactive exhibit company. And our main webinar series has been all about our latest technologies. However, this one is not about our company or our normal work-related AV and interactives. With all the webinars that talk about getting back to work and safely reopening your businesses and other venues, we felt that we should do one that wasn't just talk. We wanted to help you with some practical ideas just to show what we've done to make our building safer for our team to return. You may not be able to do all of this or indeed find it necessary to do all of it. However, we felt that it was imperative that we did all we reasonably could to protect our staff as well as we can. And we expected that we would make some changes and some during the development of us coming back to the office. So our team is our company, and we need them all healthy, and minimizing risks is always at the core of what we do. And with professional engineers at the core of our company, it's only logical for them to take this on, as they always take on projects seriously and in depth. We're very clear on the problem. We have a virus. The coronavirus particles are surrounded by a fatty outer layer called the envelope and usually appear spherical, as seen under an electron microscope with a crown or the corona of a club-shaped spike on the surface. The only way that we know to disable this virus is to damage the fatty outer layer, and that can be done by using chemicals, applying ozone, which is O3, or applying ultraviolet UVC. So the aim is to do all the sensible things, social distancing and wearing masks clearly are at the top of the list to control things. You want to aim to reduce the risk of getting the virus in the building at all, to reduce any viral load that will ultimately, of course, arrive at the building in one way or another and limit the exposure of people to each other. So I'm afraid hugs are out for now, unfortunately. And that means that anything that gets into the building should be treated with care, from people to incoming goods. Zoom calls will continue to be a great way to communicate, both for conversations with clients as well as for internal meetings where there's no need for people to sit across the table from each other. So let's face it, it's a very low-cost option to provide 100% level of safety for meetings, and everybody has smartphones, tablets, PCs that we can run video chats on. Now, we know that washing our hands and using Clorox wipes and bleach solutions are a good way to neutralize the virus, but that doesn't help with things we touch or space we occupy in the areas that are hard to wipe down. While on the subject, let's be careful when you're using materials such as bleach. Make sure that you're only mixing it with room temperature water, and don't mix it with anything like vinegar or cleaning materials, as the result could release toxic gases into and make you incredibly sick. Let's first look at a couple of methods to damage the virus other than the ones we just mentioned. The first interesting option is ozone. Oxygen is O2, so two oxygen atoms combine together. If you force three oxygen atoms together, you create O3, which is ozone. Coronaviruses are classified as an enveloped virus, which are susceptible to physicochemical challenges. They do not like being exposed to ozone. Although there is little evidence that ozone neutralizes this specific virus, we do know that it takes care of SARS-CoV-1, which causes the SARS disease. It's therefore believed that ozone will also be effective against SARS-CoV-2, which is what we're dealing with here. Ozone destroys the coronavirus by breaking through the outer shell into the core, resulting in damage to the viral RNA. Ozone can also damage the outer shell of the virus in a process called oxidation, basically exposing the coronavirus to a reasonably high dose of ozone to an extended period of time is likely to sterilize the area where ozone is present. We have purchased some ozone generators, which we use for about 4 hours every night to purge the office, and we recently had a scare. So we sent everyone home for the day and ran the ozone just in case, which sterilized the whole building. Since ozone is a gas, it will get everywhere where there is access to the surface. The problem is that you can't use ozone when there are people in the space. It's very, very bad for you. So it's really important to make sure that there's no ozone where there are people. So you may need to make sure the building is cleared from the ozone when re-entering the building. Another way to affect the virus is with ultraviolet light. And a good dose of the right wavelength will neutralize the virus very rapidly. This image that I'm showing here shows the electromagnetic spectrum, with the insert being the visible part of the spectrum. To the left of the visible part of the spectrum, in this image, you can see the UV, X-ray, and then the gamma rays. The ultraviolet spectrum starts on the visible blue end of the spectrum and goes towards the soft X-ray. It is the part of the spectrum known as the UVC. That is the most effective, with an optimal wavelength apparently around 231 nanometers. Sunlight contains those wavelengths, but the upper atmosphere attenuates them so that we only get a UVA and a UVB at sea level, which are not effective against this virus. The way this works is that UVC damages DNA. So that is how it neutralizes the virus. The snag is that UVC damages DNA. So we have to be really careful not to expose it to anyone. So we need to create our own UVC in order for this to work. As mentioned, the problem with UVC is that it's very unhealthy and it causes skin cancer, and it can produce ozone by breaking down air molecules. So again, we can't expose people to the standard UVC. We have UVC light that we installed into our break rooms and into our restrooms. And we use a combination of door sensors, making sure that the doors are closed, and motion sensors to make sure that nobody's in the space and going to get affected. And this controls the UVC exposure to the areas. As a matter of interest, the area of the spectrum right next to the X-ray is called far UVC. Far UVC does not appear to cause skin cancer, cataracts in the eyes, or other problems to humans. So scientists are very hopeful that we can use far UVC to kill the virus without causing damage to people, which means that we can outfit airports and other public spaces with far UVC light fixtures to continuously sterilize them and make it a lot safer. So, sorry, I missed that, that slide with a nice little bus getting UVC. In our office, we all wear masks wherever we can. especially when we're not in our personal working area. It's not only that we want to protect ourselves, but we also want to respect others' health. And so it's worth the inconvenience to us. We also maintain social distancing wherever possible. And we have one corridor where we can't, as it's just too narrow. So we have the corridor, it's just too narrow. So we have sensors in the corridor that turn on and they turn red to warn everyone that someone's in the corridor so that we're avoiding people from trying to pass each other unnecessarily. We'll be severely limiting the use of our conference room. We've already proven that Zoom meetings can be held by individuals on their own computers, so why put people into a conference room to do a Zoom call when we can do a Zoom call? Of course, when we have visitors, that's a different issue. And we've purchased some one-time use plastic chair covers to provide a level of safety, although ultimately the idea is to keep enough time between meetings and presentations to allow the virus to naturally disappear, but you know, in any shared space. So the ozone generators will help to sterilize those rooms every day. We've changed the way that we handle incoming goods. The various delivery people leave the smaller packages on the rack shown here in the screen, in the slide. We don't sign for stuff anymore. That's gone by the wayside for sure. No need to go out there and verify the packages right at this point. Any packages that we need to get to that day that contains things that we need that day are sprayed with Lysol before opening them after a couple of minutes after delivery. The outer package is always left outside and there's no need to bring that into the building. And if we know that the content was packed recently, that is within the last couple days because we've ordered it and it came very quickly, then we spray that down with Lysol too before unpacking it and using it. Larger deliveries go to the back, where we pick them up and with the forklift and we store them in a separate area in our workshop where they'll stay overnight so that they're flushed with ozone in that part of the building. With the knowledge of our engineering team put together a list of things that we wanted to do. This includes simple solutions to reduce the need to touching things. We've put in a touchless thermometer at our front entry for our employees' convenience, keep a track of their temperatures if they like. We changed out our trash cans to be pedal operated. We purchased automatic soap and sanitizing dispensers for our restrooms, break rooms, and entry, and we've made sure that everybody has their own personal gel dispensers in their office and in their work areas. We changed out our faucets in the restrooms to automatic faucets, and we changed our toilet handles to no-touch flushing toilet sensors. We changed out our most used doorknobs to handles, so you can use your elbows and things like that to open them, and we added little foot controls so that you don't have to touch the doors at all. You can actually open them with your foot and close them without touching them. So we're adding some acrylic screens as barriers between busier walking areas and that people are working in to provide a better level of separation between the two. And of course, it turns out that everybody is buying sheets of acrylic. So we're still trying to get a hold of that material. We added an intercom by the front door and the rear door so that our teams can respond to people without having to go to the door and handling and having delivery people enter our building. We created an external delivery area with an open metal rack where the UPS and FedEx, of course, in the other screen you saw, and the postman can leave their deliveries. And we replaced our bottled water cooler with a filtered version so that we don't need to have bottles delivered, and went for a touchless version also. We added UVC lights in the kitchen, and in fact, we added 2 to reduce shadows, as a problem with UVC is that nothing happens unless the light hits it directly. In most cases, reflected light is unlikely to work. When both of the doors in the kitchen are closed and there is no movement, there is an alarm that sounds before the UV lights are turned on to sterilize the kitchen between uses. We use a programmable logic controller, and that also turns the lights on and off after while we need to avoid them creating ozone, which the hard UV lights will do. One of the current concerns we had was with the air conditioning, which we needed in summer. And we found that has been proven to spread through the virus. So we added a UVC light in the return feeds of our 3 air conditioning systems. These lights are UVC, but they are chosen very specifically not to create ozone. In the later afternoon, we take our incoming good rack from the front door and we move it into the reception area. And anything that we didn't need that day stays left on that rack. And at night, the last person to leave turns on these ozone generators that we've purchased so that there's time for everyone to leave. They're on a little timer. And they run for about 4 hours each night in various areas of the building. And at that point, when those they turn off, the fans on the air conditioners are turned on and it purges the building to clear the air. Now, the minimum recommended amount of time of purging the building is 30 to 60 minutes, but in our case, we're running it for many hours before returning to the building so that there is absolutely no risk of exposure. This means that any incoming goods that were ozone flushed and therefore safe to open the next day, and we can put them away and everyone can handle them with no issues. We ozone flush both the warehouse and the entry area. So this week is week 12 for us, all working from home, and ultimately, and in spite of all these changes and precautions that we've taken, we are still not in a hurry to get everyone back into the office to work. Yes, we will have a few back in working over the next couple of weeks, but considering the level of productivity that we've seen during this period, we don't really feel that the risk to our team is worth getting everybody back in immediately. We'll take a very careful approach as we transfer from work to home and back into our offices. So now it's time to see the demo. I'm going to hand this presentation over to Maris, who will show you the result in our building. Although the changes are significant in terms of providing a safer environment, the impact to our normal day-to-day working is minor, so that it does not make a difference or difficult for us to live with. After that, I'll meet you back here for Q&A. So please use the Q&A panel or the chat panel to pose your questions. Maris, let's see what the office is looking like and the changes that you've made.
Good morning. My name is Maris Ensing, and I'll take you through our office today. So the first place we're going to go is outside. We have a mag lock on this door. We've had that here for years. And what we're doing is that we've taken a wire rack, and the reason it's a wire rack is so that the ozone can flush around it better when we put it inside at night. So we have a wire rack where they leave the mail in the tray, they pick up the mail, and they put any packages on there. Anything that we need that day, we'll spray. We have a Lysol, bottle of Lysol sitting there, so anybody who needs something can take care of that. If it's not needed, it stays on the rack, and then we bring it in. Other changes that we've done outside here is that we've added an intercom so that anybody who needs attention can just go to the intercom and ask for whatever it is that they need. We have one at the front door, we have one at the back door, and we have a couple of intercom stations around the office so that we have multiple people that can actually answer that immediately if it happens. The other thing that we will be doing is we use our facial recognition running here so that when our staff or other people that we want to enter the building arrive, we can actually open the door for them so that it is automated as well. So if we go indoors, the first thing we come to here is a non-contacting thermometer. so that people can actually make sure that they can take the temperature in case we're concerned about that, and we can handle that. And then the next thing you're going to see out here is that in our reception area, we have a small gel dispenser. It's nothing special. It just means that you can clean your hands if you come into the building, as you come into the building, which is a good thing. As Tricia's already mentioned, each one of our staff members has their own gel at their workstation, so everybody can use their own as necessary. Then the next thing we have is that narrow corridor that we mentioned is here. And basically, it's narrow enough that we felt uncomfortable having people just walking in and out and bumping into each other, because our kitchen is off of this corridor. So what we've done is we put some sensors up, and you can see the red light coming on when there's somebody walking around in the corridor. So as I'm walking through here, you'll be able to see that. Now here's our kitchen, and the ultraviolet light has just gone off. Basically what is happening in here is that when we enter the kitchen, we turn the light on. When we enter the kitchen, there is a sensor up at the door that makes sure that the ultraviolet light is turned off. It's just a simple alarm sensor that you'd use with a burglar alarm for door opening sensors. And we have two doors, they both have a switch on. You can see the ultraviolet lights that we've installed, and there's two of them, one over there to the right, which is where Jessica is now, and there's one over to the left over here. And these are fairly high intensity ultraviolet lights that run for a couple of minutes every time that we're not using the kitchen. So there are motion sensors, motion detectors over the two doors that look at the space. So if we find that both of the doors are closed and there is no motion in here, after about 3 or 4 minutes of no motion, we sound an alarm. There's a beeping sound that happens in here that just warns anybody in here, hey, you'd better move, to make sure that the UV doesn't come on. If they do, then the cycle is reset. If there's nobody in here, we just run the ultraviolet light and sterilize the whole area. The other thing that we've done, and you can see the remnant of the way most people are doing their water coolers over here, you have these water bottles that somebody has to deliver into the office, which we really didn't like, because the delivery guy that delivers these bottles comes in every week or every couple of weeks, and the problem is that he has already been to whoever knows how many businesses before. The other thing we didn't like about this water cooler is you actually have to touch these buttons in order to make it dispense water. So what we've done is we've changed the whole thing over to a filtered water cooler. And this one, you can just take your cup and you can push your cup against it and it will dispense water. And it's filtered water, so it's effectively the same quality result. We still provide fully filtered water to our people, but you don't need to touch it, and we don't need to have bottles delivered anymore. And that is basically what we've done here in the kitchen as basic measures. Now, of course, you could do this yourself as well with timers. The only thing that you need to be really careful with is to make sure that you cannot have ultraviolet light visible in this space when you have people in here. So let's move back, and I'll move back over to the lab. So that's what we've done in here. Actually, we'll go into the restroom first. The first thing we did in the restroom is we used to have doorknobs on these doors, and the problem with doorknobs is you can't open them with your elbow. So doorknobs like this, you can just open by pushing against them and opening the door. Once you're inside, we have a door mechanism over here that you can use with your feet. So opening and closing doors, we are retrofitting most of the doors that are relevant to the building with these foot devices. They're a couple of bucks on Amazon, and it really helps the process because you no longer need to worry about opening and closing doors. And the other thing that we've done is this standard doorknob had a recessed pin for locking it, which obviously doesn't work. So the guys have just put a little foot on it. You can use like a rubber foot from a piece of equipment or something so that you can lock it by just pushing against it instead of having to worry about anything else. And to open it, you can just get in here and do your thing. The other thing, and here is where I have to admit I screwed up, We have standard trash cans, and we are replacing them with foot pedal-based trash cans. The snag is that this turned out to be a fraction of the size that I was anticipating. So it wasn't quite the result that I wanted. We're ordering some proper sized ones. On the toilet flush, nobody wants to touch the toilet handle. So these ones are automated toilet handles. You just you put your hand over it and it will flush the toilet. So touch is no longer required. The soap dispenser, we've changed over to a non-touch one, and we've changed the faucets, which was a dead easy process with non-touching variety faucets. So that's taken care of it as well. Over here, again, you can see that we have an ultraviolet light in our restroom with the motion sensor over there on the wall with the relay that we've put in for the time being, so that if there is no motion in the restroom, we have a PLC, a programmable logic controller, that we're actually running to control this. So if there's no motion in here for a preset period of time, then the ultraviolet light will run for a while in order to make sure that we sterilize the restroom. So here we go. I have to get used to this foot handle like everybody else will have to. But now we can safely open and close this door and just do what we need to do. In the lab, Tricia mentioned that we have another corridor over here. And as we're walking through the lab, it's a fairly busy area normally where we're going in and out of the warehouse. And this corridor is a problem because we have people, we have workstations to the left and to the right. And so we are adding screens over the top here, acrylic screens, so that people walking in and out do not emit any virus, even if there is an issue, to the people that are sitting there, so that we're just creating a safe barrier between the corridor and these working spaces. The other working spaces have a lot less traffic, so we have far less of a problem in those areas. And then the last thing that I wanted to show you is the ozone generator, which we have over here. Tiny little thing, you pick it up at Amazon. They're actually 120, 150 bucks or something like that each. You turn the power on. The last person that leaves the building turns the power on all of these devices. And all you need to do is to press the power button. It is pre-programmed to run for 4 hours. So these are turned on. You leave the building. After you leave the building, these things start generating ozone for 4 hours. And then we've programmed our air conditioning units, which also have UV built into the returns. And that actually turned out to be a bit more work than we anticipated, because we had to get power to those lights. They're on 24/7. And as Tricia already mentioned, these are not just the ones we bought for the other parts of the building where we can ventilate things through. Because they're in the air conditioner, there are UVC lights that you can buy that are at a specific wavelength where there is far less of a chance of them creating ozone. So these are ozone-free UVC. It's a wavelength that they've selected for those lights. And that's basically what we've done within the building. It is not a huge amount of work. We spent, some money on it, but it wasn't hugely significant. And I feel that what we've done now is we've created an environment where we can honestly say to our people, yeah, you're safe to come back to work. And we've done what we can to look after you and make sure that we create a safe working environment. So with that, I'll hand it back over to Tricia, and I will join her for any questions you may have.
Thanks, Maris, for that demo. Let's move on to the Q&A portion of the webinar, and we'll take some questions now. Let's see here. Let me go over and see what kind of questions we have. All righty, come on in, Maris.
So the first question is, have you done any testing of your spaces after ozone flushing to check for active COVID-19? And how do you ensure the security of mail and packages while they are left outside throughout the day? Well, let's start with the mail one. The fortunate thing here is that the estate is not hugely busy, the area we're in. So, and because we have our own area in front of the door, it's pretty quiet. And we know all of the neighbors of the buildings around here. So we have absolutely no concern of anything disappearing, really. And that is the advantage of our location here in Orange, I guess. The other one is a bit more complex. And the answer is no, we haven't tested for COVID-19. We really can't because you have to do active testing. And the only thing that you can do is to take the scientific evidence that is out there that ozone will kill the virus. It's the same with UVC. Pardon me. That is not a dry cough that you need to worry about. So basically, no, we cannot do a before and after COVID-19 test. I've thought about, how could we do that, but there isn't an easy way of doing it, so we haven't been able to do that. So our approach is basically science-based. We know that UVC will kill the virus. We know that ozone will kill the virus. They're talking about running a UVC light through on other tests that people have done, for example, in public transport for a couple of minutes. And it's the same in surgical theaters. They're sterilized for a limited period of time. And by emulating what these other people are doing and exceeding it by a reasonable amount, we feel that the result we have is better than nothing and most likely efficient.
Would the UVC light work in the bathrooms with multiple stalls?
Yes, they would, but you do have to be careful about what you're doing about location, because obviously if anybody is facing a stall, or inside of a stall, you're going to have to add more lights than we have in ours. So if you have multiple stalls, my recommendation would be to run multiple lights in that space. I think you kind of have to. Actually, let me appear in this picture. Are people allowed to eat in the kitchen, or what arrangements have you made for people eating at work? It's an interesting one, and it's still a discussion that we're having.
Yeah.
And basically what we're intending to do when people get back is that everybody will have a Tupperware bin that we'll put in the fridge. People will be able to sit and eat in there, but one at a time. Several of us, including me, I tend to eat in my office, so it doesn't really matter too much. So we're seeing the kitchen as a prep area. And because all of our people have somewhere to sit, and because all of our people have somewhere that they can be, most of us eat at our
desks.
At our desks. So it really doesn't affect us too much. There's a few that like to sit in the kitchen, and certainly we used to use it as a social space. Mm-hmm. And I'm afraid to say that at this point is really not an option. The kitchen is relatively small, and keeping 6 feet between people is not much of an option. So people will be asked to eat at their desks and use the kitchen as a prep space only. And that really is the only thing that you sensibly can do. I did not see elevators. Yeah, we don't have elevators. If we did, I'm afraid to say that we would recommend that people go up the stairs because elevators should be reserved for people who really need it. And that way you can reduce traffic in the elevators. But this is Orange County, and I'm not sure how many elevators there are, but it's not an awful lot. So that's one problem we didn't have to face. But as I say,
but could you use UV lighting in an elevator?
Yes, you can absolutely use UV in an elevator. There's no reason why not. You just need to make sure that you get rid of the UV as soon as the doors open, and you can do that with motion sensors and with simple contacting sensors. So converting an elevator to put UV in there when there's nobody in the elevator and just running light in there would not be that hard to do.
And what about the new UVC?
So the far UVC is a very interesting thing to look at. The wavelength is a lot shorter than it is for the UVC that we're using. There are very few products out there at the moment that you can use. But the hope is that the shorter wavelength does not cause skin cancer and does not cause eye problems. So hopefully we'll be able to get to the point where you can actually permanently run far UVC lighting in public spaces. The one company that is worth talking about is probably somebody like Christie, because they have a lot of light sources and that kind of thing, and they're doing some interesting research on that subject. So it's probably something that we're going to see more and more of, but we've done a search for far UVC lights and I haven't been able to find anything that I can just purchase.
So is that all of them?
And I think that is all that I found. So one other interesting thing that Graham Owens brought up, some interesting cameras to be able to do temperature sensing. So temperature sensing using infrared cameras is a very good way of doing it. And we just found that the cost of the infrared cameras was not something that a lot of people are going to be happy to spend. I've been looking at a couple of them. We will probably end up buying one. There's another one that is of interest, which is one that hangs on the wall. So it's a non-contacting thermometer that hangs on the wall that you can just walk up to and it'll give you a green light if there isn't an issue. And that seems like a more affordable solution that does everything that you would want it to do. There's one other thing that is actually of interest while I'm talking about some of these issues. We actually had a scare here last week. Not anybody that was in the building, although she was here briefly, but we had somebody that had some symptoms, and so we locked the building down basically, and the few people that were here were immediately sent home with instructions to self-quarantine for a few days while we were getting a test done. The test came back negative, so all was well, but it does make you realize just how easy it is for a situation to happen, for a pretty unhappy situation to happen. And so one of the things that we have been talking about is contact tracing for ourselves, because there still isn't a contact tracing app out there, which we desperately need. And one of the other things that we're doing here is we're actually looking at people's phone signals, because when we walk into the building, we're logging into all of our phones, automatically log into our Wi-Fi system. So we're looking at doing something with our Wi-Fi system whereby we know who is in the building when, and if we do need to check a log so that we can do proper contact tracing, we can handle that. The other question here is, do we use ozone sensors of any sort? No, we don't, because the ozone generators tend to go on at about 4 in the evening. They run till 8, or if somebody really stays late, they might run till 10 or even until midnight. But with a 4-hour runtime, they'll never run any longer than that. Recombination time of ozone to oxygen is in the order of half an hour. So an hour max. And so by allowing at least 4 to 5 hours before the first person heads into the building in the morning, we really don't feel there is much of an issue. And I don't know if you smelled ozone, but certainly when you walk into a building, when we were doing experiments and you could sniff it, you can really smell it. It's a very distinct smell. So no, we're not running ozone sensors simply because we know that we're running the fans on the air conditioning.
And that really helps a lot.
It really just cuts the whole thing down very quickly. So there isn't an issue. Any other questions? Oh, there's a few more. After the 4 hours of ozone has finished, do you pump new fresh air into the building?
Yes.
You actually don't need to, because O3, 2O3 combines into 3O2. So the ozone recombines into oxygen, and it's not a gas that is stable. So O3 will recombine into O2. It just goes back into oxygen. You've pumped it up and now it kind of goes back into its normal form. Having said that, because we do run the air conditioning in the building, we are getting fresh air in, but we don't really need it. What plans do you have for personnel who cannot wear masks due to health reasons? We don't have any of that. So to be honest, George, we haven't actually looked at that at all, because what we're doing here is that everybody who is walking around the building wears a mask. Anybody at their workstations can take their mask off so that there's no particular reason to keep it on while you're seated at your workstation.
And anyone,
because we have space.
And anyone that knows us, Maris and I are partners, so that's why we're not concerned about wearing masks sitting here together on this screen.
Yeah, we spend a lot of time together at less than 6 feet. What effect do the ozone emissions have on smoke and carbon monoxide detectors in the building? None whatsoever. Like I said, it's oxygen. It's three atom. It's a 3 atoms type of oxygen. So it's nothing that is going to affect any other sensors in your building. There's no concerns about that at all. Use for water purification on ponds, yes. The cost of the, so Graham mentioned that we don't have air conditioning in our office, so we would need to allow a regressive period of manual flush. I think that if you run it in the evening and make sure that you have an overnight period of more than a couple of hours, then the ozone will be gone. If you smell it and it has a very distinctive smell, then obviously you have an issue. When we first started doing this, the only thing that we did here is that we run the ozone generators and then we flush the building through. In your case, in England, because you don't have air conditioning in that building, I would just put a fan by the front door and push some air through if you're concerned about it. But if you're stopping the ozone generators running at about midnight, then I think it is highly unlikely that you're going to have any ozone left by 4 or 5 in the morning.
Too. Getting a sensor,
and you could get a sensor for it. Yeah.
Be aware of if it's a concern.
You might want to check with NIOSH on it affecting your carbon monoxide detectors. They're saturation detectors and the ozone can compromise them. We'll check up on that and see if there's any concern on that, but we haven't had any indication that there has been an issue, and we've been doing this now for about a month because we do have 1 or 2 people that are in the building fairly regularly, well separated, because the building is big enough that a couple of people in here just don't even need to see each other during the day at all. So we haven't had a problem thus far, but we'll certainly check it. Thank you for your information on that. We'll keep an eye on it. If there are no other questions, then I think that we are running on time, to time. And thank you very much, everybody who has joined us. And we hope that it helps you preparing your building to do what you can. As Tricia mentioned earlier on, our team is our company. And so anything that we can do to help the process is something that we will do. And realistically, by the time we get into the building and we start using it as it normally used to be, we will undoubtedly learn more about things that we may want to add or change. I just noticed that we still have doorknobs on the kitchen. So we'll have those replaced in the next couple of days with door handles, so that that's taken care of. And we're still waiting for some of those little food brackets to come in. So do us a favor and don't order any of those for the next 2 days from Amazon, because I still need to get a few more. But apart from that, do what you can and let's beat this thing and get rid of it, because this has taken a long time already. And we'd certainly be delighted to have everybody back in and being able to get on with the normal daily life. But fortunately, everybody here has been pretty efficient. So as you've seen from our webinars, An awful lot of new stuff has been developed in spite of the fact that we haven't been able to work from our building.
So thanks for joining us on this webinar today. And remember that this one was our special webinar and not part of our technology series that we've also recorded. And in 2 weeks' time, we'll be adding the Quicksilver Toolbox webinar on Tuesday, June 23rd at 8:30, which is the last one of our technology series. We had to postpone, of course, we said because of a little scare that we had, and thank God it was a false alarm. You can find us online at madsystems.com and our social media platforms, Twitter, LinkedIn, Facebook, Instagram, and YouTube. And this webinar is being recorded and it'll be up on our site very shortly. All of the past of our webinars are also available through our website at madsystems.com. We'd like to thank InPark Magazine and Blue Loop for helping us to promote our events. And if you've missed any of our AV++ webinar series, make sure to check them out and share them with your colleagues. You can find them on our website as well as our YouTube channel. And thank you again for joining us. We had a lot of fun doing this, and we hope that it was informative of MADS prepping for our workspace during a post-COVID work environment. Thanks again. Feel free to contact me online through LinkedIn or Twitter or via email. I'm Tricia at madsystems.com. Take care, you guys. Stay safe, and I'm really hoping to see you guys all again soon, either at conferences or in person. Take care. Bye now.
Bye-bye.